Yeah.
I know, sir, you are in another session, by
Where
the
is
way.
Lakshmi?
Lakshmi is joining in 10 minutes, sir.
He was giving, he is urging me to join, and where is he? He's not there.
Yeah, yeah. She's just calling you frequently. She was just telling me that.
Yeah.
Okay, okay, sir.
Okay.
So we
How
are
we
live
will
on the
join?
YouTube as well, sir. Okay.
Sorry.
We are live on the YouTube as well.
Okay. Okay. Right. No problem.
Yeah. At the same time, we are live on the YouTube as well.
YouTube.
I'm just saying.
Right.
So can we just start, sir?
Yeah.
So,
We ready.
okay. Okay, so I'll just, as the same as usual, so I'll just introduce you and then we
Yeah.
can just go ahead for the
Go
session.
ahead.
Hello, everyone. So, good evening to all of you. And as you already do know, this is the Indian Space Week, in which we were having lots of lecture series. And before this session, you have joined the two session. First one was the Deepak sir, and then we were having the another sir as well. And we have been discussed lots of topics, but today's topic is going to be a bit different because it was always needed as well. Lots of people just keep asking what are the plans future is like ISRO is having and how it is going to be get done and all. So all these things is going to be get done today. And today we are having Elangovan Rajagopalan sir. How many of you already do know? I know lots of people already do know about this sir, but I would like to introduce him again. If you do not know about this sir, so sir is just such a great personality. Sir has done lots of things till now. Sir was he is a former scientist of ISRO, but currently he is the director of Bharti Aerospace, advisor in different companies. Okay, there is a lots of company where sir is the advisor. Even he is also being at the Indian Space School as well, and we are having the privilege to have him always at a platform in frequency. So today, sir will just going to take the session on the future technology for the space mission of ISRO's. Okay, so without wasting a single minute, because you are already waiting for the like 10 to 15 minutes, we'll just continue that. Thank you so much, sir. Thank you so much for joining today. And sir, please continue the session. Uh, I'll just make the course to you, sir. Yeah, please continue, sir. Hello, sir. I'm done, sir. Please continue, sir.
Yeah. Just major problem is my laptop.
Oh, in the sharing the screen, sir?
Yeah. Sharing the screen is not allowing. It's not moving. My
Okay,
cursor
not
is not
allowing.
taking the position.
You're the co-host, sir. You can do that.
Yeah. No, no. It's very simple. Cursor is not fixing. It is disappearing. It's not selecting.
Okay.
It's a
Sir,
clear problem.
you could just share with me. You could just share with me. I'll just share it.
Yeah. All right. I think it has come. Just see. That's okay. Are you seeing what we are seeing? The first slide?
Sir, it's not visible till now. Your screen is not visible.
Is a major problem.
Sir, if there is any issue, what you can do is you can just share with me, sir. I'll just share it
No,
from
I
my
cannot
device.
share that time. Cursor moving is typical. It is not doing properly. It is sticking to the, not coming out, or it will disappear. And it's going the unrequired places. It's going.
Okay.
That's all.
Abhimanyu, stop doing this.
The selection is a problem. It is not selecting properly.
Okay.
Cursor
Sir,
is not moving. I am seeing the PowerPoint
if
and
you can,
everything. Cursor is not moving.
okay, cursor is not moving. Uh,
Uh,
sir, you could just share with me PPT if you want.
See, even a small operation is problem. That's what I'm telling. To share with you, you have to
Oh,
open the email. It is better to. Okay, now it's okay. Let's see. Just now they come and come. Yes, it's coming now.
yes, yes, yes. It's been happening, sir. Yes, now it's fine,
Yeah,
sir. Yes.
what you are reading?
Yeah, yeah. India space essence, sir. Yeah, it's happening.
Okay. Yeah, it is
Yeah.
going to the second slide. Now I am moving to the second slide. Whether it's moving, just see that.
Yeah.
Now moving
Yes,
second
yes.
slide.
It's happening. It's happening, sir. Yeah, now it's
Okay.
happening. Yeah.
So that's what. Okay. The problem is my see. So ISRO rocket revolution. See, I am mostly a rocket man, then a satellite man. So I'll be mostly talking the future projects of ISRO and future what are the key technologies required for each project we will talk now. Okay, that will be the 1 hour talk. After that, you can ask me any question. So rocket, our ISRO has gone lot of eras. That means first era was with sounding rocket era. That is even before joining SLV. Sorry, even Dr. Kalam joined the ISRO. There were activities were going on for sounding rocket. Sounding rocket is 1963. The 60 to 70s. We are launching first rocket was launched was the American Dickey Apache rocket. It is not Indian rocket, but American rocket launched in India. But Indian sounding rocket launched from India. That means Tumba Equatorial Rocket Launch Station. It was on 1967. It is Rohini 75. The rocket name is Rohini 75. 75 is the diameter of the rocket in millimeter. Okay. 75 millimeter was the diameter of the first rocket what we launched from, raised from ISRO soil. Then comes SLV3. We slowly developed our rocket technology too. The next technology leap is to send a satellite to the orbit. That is a mission. Of course, at the time, Vikram Sarabhai was not there, Kalam was there. So he started the project, but Vikram Kalam continued the project and launched the satellite in 1980 successfully. We use the same solid propellant technology. All the cells are solid. The satellite weight is which we are launching is only approximately 30 kg. Now we are trying to launch in the future 30 tons. That means 30,000 kg we are now going to launch in the future, where our first rocket is only 30 kg satellite only launched. Then comes era 3 was a ASLV. Most of our people may not be seen this vehicle. It is the most unsuccessful way of ISRO, 50% failure. Only 4 or 5 launches only, but all the 5 are failure. That is because of the technology. But it was the learning bed of ISRO, I can say ASLV. Because we have launched we attached along with the core two stop on, which is equal to the first stage of SLV. This first stage, this one, and this one are same. Same, the S1, what we call as S1, is attached. It taught us lot of aerodynamic problem, ignition problem. All the things lead to failure of this one. It's the braking of vehicle. Everything is automatically started. And we learn lot of things by failure from ASL. PSLV was the next one where we have replaced the second stage. This second stage is by a liquid propulsion. Okay, for a liquid propulsion, first time India is using in 1993 liquid propulsion engine. We have made such a way, it is the first stage is solid, liquid, third stage is solid, again fourth stage is liquid. Like the solid liquid combination was the invention of the technology at the time. This was served like anything. This is even now, it is a workhorse of ISRO. It lifted tremendously from far. Our payload was only 40 kg in the era 1, era 2. But when it comes to PSLV, it is 1,000 kg because of the liquid propellant index. It is a polar orbit. It is a polar circular orbit of 400 kilometers above the Earth. But this is a vehicle which takes us to the Chandrayaan-1 to the moon. Chandrayaan-1 to the moon, Mangalyaan-1 to the Mars. Okay, this is a vehicle which can lift satellite to the distant places. But we need but it is a sun-synchronous orbit and polar orbit. Next comes era 5 is the GSLV Mark 1 series, GSLV series. Here we have done a technology, this one is, we put this a cryogenic engine, a cryogenic stage in the vehicle so that our ISP will improve. It is only 3 stages. It reduces the vehicle from 4 stage to 3 stage. Third stage being a cryogenic stage, it can lift more weight to the distant orbit like 40,000 kilometers. Whereas SLV is around, whereas the sounding rocket go up to 100, SLV will go up to 300 to 400. ASLV also 400. PSLV also polar orbit 400 to 600. But GSLV is 40,000 kilometers away from the Earth orbit. That is called communication orbit, geosynchronous orbit, which takes 24 hours to orbit the Earth, equal to the Earth. So this was our technology. We use a cryogenic engine, which was given by Russia. 7 stages. And then we developed our own cryogenic stage, that is GSLV Mark 2 and GSLV Mark 3 are the serial where we have put our own Indian cryogenic stage in the vehicle. The tremendous increase in the payload to 4,000 to 4 ton to 5 ton. Okay. Next we start sending satellite. We start sending a human being in the module called crew module with a land escape system that is called the Gaganyaan type vehicle, human rated vehicle, is a human launch vehicle Mark 3. We can say HLVM3. When the satellite is there, is a LVM3 for a heavy satellite, communication satellite or etc. Even our Chandrayaan 3 went by that the LVM3, you all know. So this is what the technology leap, and we are now sending the man in the orbit. That is the starting point. As it of none is there. Now the project is Gaganyaan. Gaganyaan is our baseline. Right? That is our baseline. Gaganyaan is the next future for project number 1. We will see one by one. So as I told, we have from sounding rocket to Gaganyaan, we have come. Right? It is all after 2027, 2028, we are aiming to Gaganyaan. Right? This is what this one. So it increased payload. So we slowly increase the payload to 40 kg to 40,000 tons. Sorry, 4,000 kg. That is a major event. We are going to in the future 30,000 kg. We started with the 30 kg in the SLV3 and now we ended up 3,000 kg or 4,000 kg in Gaganyaan. And we are going to end up with 30,000 kg in NGSLV is the latest vehicle which is going to come. Not only rocket, ISRO has developed a lot of landmark satellite. The evaluation of the satellite from Rohini RS-1 is the first satellite, Indian satellite launched by Indian vehicle from India. Aryabhatta, don't confuse with Aryabhatta. Aryabhatta is the first satellite Indian satellite launched by Russia in Russia. That is the difference. So IRS-1, Rohini 1, which is around 40 kg in 1980, successfully launched by SLV as a project director of Kalam. I am an ordinary project man in the core team of SLV-3. Then the remote sensing has started. ISLV would cover remote sensing. Remote sensing it will be it will be observing Earth in the lower orbit, in the polar orbit or sun synchronous orbit, whatever you call. Then 600 kilometer it can go up, and this it started monitoring the Earth images. That is the PSL. Then we got a satellite which is used for communication, which will be launched in the 40,000 kilometer above the Earth in the orbit. This series with a heavy of 3 to 4 ton weight. So that will be used for a communication purpose. That is a GSAT. Then IRS-1A is a double group of layer of satellite in double orbit, which will govern us for the GPS. It is a local GPS of our India. Instead of GPS of US, we can use a GPS satellite of India, which is used for IRS. Then comes Chandrayaan 1, 2, 3 serial. Chandrayaan 1 launched by PSLV. Chandrayaan 2 by GSLV. Chandrayaan 3 by LVM3. Okay. Chandrayaan 3 serial come where we first time we send a satellite to moon. Then Mangalyaan 1, which will be sent to the Mars, which is not there. Aditya L1 is a Lagrangian point 1. It went to the Lagrangian point 1, which will be observed as a sun continuously. So lastly, we have come to we are sending a satellite is called human spaceflight satellite called crew module. There are even Apollo, so there are 3 modules: crew module, service module, command module. So command service module CSM, and the third module is landing in the lunar. That is called the lunar module or moon module. So CSM. But now we are not landing on the moon. We are just orbiting the Earth and coming back to Earth. So we have 2 modules, that is called crew module and service module. The crew module is around 5 to 6 tons, where 3 people can live in the crew. Remember, even though the feat was done by America, the first time, Russia in 1961, Yuri Gagarin orbited Earth just for 100 minutes. Only one orbit, one person. But here, India is going to orbit the Earth 7 days, 3 person. See the difference. Even though the first orbit attempt of the country, we are going slow, but we are coming steady, and we are the latest. Right. So that was the technology improvement in the satellite side. Right. This is a review of the thing. Okay. So we have a lot of satellite program. Apart from the milestone satellite, we have a lot of application of the satellite. So we are India has diverted itself into a lot of applications. So each satellite come into each different category. The earlier satellites like Rohini, ISRO, and everything is called APRIL. They're all experimental satellites. Then comes communication satellite. We will start with G, INSAT. These are all Indian satellites. Something are launched by foreign countries like Iran, USA, everything. But we start launching our GSAT series. Okay. Then comes a remote Earth observation satellite, which requires a polar orbit or a sun-synchronous orbit of a PSLV launch vehicle. These are like IRS-1A, Cartosat, and RIASat, like that. Lot of sats are there. These are observing the images, observing the Earth observation. Okay. Then comes navigation vehicle. We discuss IRNS. Then comes lunar and interplanetary satellite like Mangalyaan and Chandrayaan series. Space and astronomy, we have done AstroSat, and another letter said Aditya L1 comes under astronomy, watching the sun, observing the sun. Third one is human spaceflight, is now the latest one, which is our reference It is a baseline for future generation. Our future starts with a Gaganyaan or the human space vehicle launch. Okay. Our baseline is not Rohini. Our baseline is Gaganyaan. The crew module is our satellite. We'll see that. Okay. As I told, so there is a lot of from 1963. It started 2024 plus. It is a Gaganyaan with the two model crew and service module. We are going to launch human to this one. We launched a sounding rocket in 1963. After 63 years, we have in the position of launching a human to the sun, and we are going to land on the moon is the future. Right? We are Apollo. We increase our capacity and everything. Okay. So there are a lot of technologies invented. There are solid propellant to liquid propellant to cryogenic propellant. Now cryogenic is going to semi-cryogenic, and instead of combination LOX and LS2, we are going to create LOX and methane. Okay, right. So this is what our this one. So each one is different object. Orbit wise also we are different, and the key innovation is first solid motor, then liquid motor, then it is a kerosenic engine, then aerodynamic re-entry, and launch support system like a crew escape system, the Gaganyaan. So this was our technological growth in the launch vehicle with respect to year, and each vehicle has a advanced technology, right? So booster technology we got in ASLV, and solid liquid propellant technology in PSLV, kerosenic technology in GSLV, semi-cryogenic technology in next generation, which is going to come. So like that, we have launched a lot of satellite, lot of this one. So it is from a sounding rocket to human space flight we have come. Right. So what are the major, we will come to a subject. So far we have reviewed the past. Now we are the slide which is telling what are the future projects, not the past project, future project. I am not going to talk about Chandrayaan 3. We are going to talk about Chandrayaan 4 and 5. Right. So first our priority, our future project is Gaganyaan. So Gaganyaan contains because unique of Gaganyaan is it is going to send a human, not in the first flight. It is the first flight, first two flight. One robot is going. Vayu Mitra is a half robot, half human, lady human robot, which will understand the instrument panel. Okay, by sitting. So Gaganyaan is our first prayer. Second is Chandrayaan 4. What is the uniqueness of Chandrayaan 4? It is on the period of 20 to 28 to 20 to 2030, they will shift. Okay, we have planned actually 2026 the Gaganyaan first flight, but 2027 is not to happen. We are coming to the third quarter of 27, not happen. So it will be, there will be a postponement. So our map is up to 2050. We are going to talk 2025 to 2050. Let us say 25. I have slides for 2060. 1960 we started 2050, but anyhow, we will convert to 2050. We will limit our future part. Chandrayaan 4. It is a return sample. We have sent rover, we have sent orbiter, we have sent the impactor Chandrayaan 1. We have sent orbiter, lander, rover in Chandrayaan 2. Unfortunately, lander outcast, but still orbiter is working. Next Chandrayaan 3, we sent only lander and rover successfully landed, but now it is not working after 14 days. So it is a success, but not working. But Chandrayaan 2 is not a success, but still working. Okay, you decide which is a success. Then comes our program Chandrayaan 5. Chandrayaan 5 is along with Japan. JAXA, like ISRO, JAXA is having, we want a JAXA. And we are going to moon, we are going to Venus. Next Mangalyaan, we are going to Venus and Mars again. So these are interplanetary projects. These two comes interplanetary. Chandrayaan 4, Chandrayaan 5 coming under lunar project. Gaganyaan coming under human spacecraft. Apart from this, for all these projects, we need a strong vehicle, which is a high ESP, which can launch payload, heavy payload like 30 tons in low Earth orbit. Not just 40, 30 kg like Rohini in SLV. We have reached stage of NGSLV launch 30,000 kg in low Earth orbit. That is called the next generation, your generation vehicle. So longer missions are there. So finally, 2040, 2050, a man will land on the moon. Meanwhile, we'll have the International Space Station for India separately. So the modules of Indian Space Station will be carried by Gaganyaan. The last flight of Gaganyaan will give the first model of Bharati Antariksha Station. So this is what the future projects of ISRO. Now we are going to see each project, what is the key technology. So Lunar 2, Venus 1, Mars 1, and human space flight 1, International Space Station 1. So these are the combined projects up to 2050. We can easily, these projects will be running out. So what are the key technologies we require? Number 1, Gaganyaan. Gaganyaan is getting postponed. Say, we have to be very important. Now we are sending human. The configuration will be not like this. The configuration will not be like a heat shield like this in the first year. It will be in the last year. When we move, it will be started. Okay, it will be like a high altitude escape system will be there. It will contain 2 modules, command module and service module. Service module, most of the instrument and everything will be there. Command module is there where the astronaut sits in. They live in. So for that, we need a environment control, ECLSS system. It must provide oxygen. It must have water. It must have food. And mainly in the Earth, we are inhaling oxygen and exhaling carbon dioxide. But whatever we are exhaling, that carbon dioxide is converted into oxygen by the plants. But in the space, plants are not. So the carbon dioxide remains. The key technology, one of the key technology of the space, going to space is how to convert carbon dioxide into what? Into oxygen. And from there, can we prepare water, convert it into water for usage. Now they are using recycling water. Even urine, sweat are also converted into drinkable water. There's a truth in the International Space Station, whether you like it or not. Then comes altitude, high altitude escape system, launch escape system, LES. In the aircraft, there will be rockets will be fired. Then that will escape from the system. That will escape from the main rocket and go there. This is a launch escape system. You can see that. That is also like a small rockets will be around. It will fire and take the people in the case of emergency. Another important thing is re-entry. Re-entry, you have to come back. The comeback re-entry will be at the speed of 25 Mach number 25. 28,000 kilometers per hour it will enter. You can imagine what kind of heat it will generate. So blend body re-entry mechanism dynamics, another key point to develop. And we have to continuously monitor because the human beings are in the satellite. We have to continually monitor the downrange station will be all around the world. That is tracking and communication. Right? First to flight, we are not sending human being. We are sending a robot, humanoid, a lady robot, I told, off-lady robot, which is AI based. So AI is based the robot technology. So these are the key technologies corresponding to Gaganyaan. One of you make a startup to find out how to convert a carbon dioxide into oxygen, a simple instrument. Or design a new large escape system. Right? re-entry mechanism is some thermal management system or a robot. So all these things are all the things are necessary for this one. Then goes this is a major problem. It is not moving. It is moving program. And so as I summarize, here also for all this program, it need advanced propulsion. We will reach the propellant mass so that satellite mass will be more. So this is what I summarize. What will happen up to 2035? It may go up to 2040. So man on orbit to man on moon. We are in between. All the projects are in between. Man in the orbit, Gaganyaan, to man on the moon, 2040. So we are in between this. All our projects are in between. Next is, I told you, Bharatiya and Rakshapal. I have to do. Yeah. We are constructing our own space station around here, like an international space station, ISS. But the technology we need is we will assemble on the orbit. We will do the assembly on the orbit. See, if you want to construct a house in the space, the orbit, you can take bedroom separately, dining room separately, kitchen separately, bathroom separately, everything, and assemble it there, like a modular construction. Right? That's why the space tech. So there will be a modular technology assembling the two modules of the orbit. It's called space decks. Experiment has been done. One module will be active, one module will be passive. It will be one module will be already in the orbit, one module will be it has to be launched. It has to be launched, and it must near the orbit go to the orbit and dock, like your space dragon entering into the docking with the International Space Station. So this kind of advanced dock system has to be necessary. A docking system has to be developed. Core system transfer, that means from one power, fluid, propellant, everything has to be for the crew transfer. All this has to be transferred to the International Bharatiya Station, BAS. After going there, you have to live like in a house. You have to take care of all your life support system, starting to your oxygen to your food, your medicine, your psychology, your entertainment. There might be a robotic assistant. Robotic technology will help you. It will give company to the astronaut. It will monitor the health of the astronaut continuously and get sending message to the earth. This fellow is good or not good or suffering from fever or etc. So these kind of technologies are available by BAS. So next one is Chandrayaan 5. Chandrayaan 5 is the joint effort with Japan. Joint effort with the Japan JAXA. We are developing the lander. They are developing the rover. Okay. They will take care of what it will do. It will do the surface drilling. It will land on the South Pole. It will do all the drilling, all the mining operation, find out, take water, rice, and everything, etc. So this is the international collaboration with them. So we are dividing what we will do, what they will do. They will do the launch also, greater expenses. Then there is a polar operation, South Pole. Landing on the South Pole is almost equal to committing a suicide. The South Pole is full of cryogenic temperature. Your instrument has to be working cryogenic temperature. If a human being go, it has to be the survive in the your instrument has to survive in the cryogen minus 120 degrees. Permanently if the oxygens are there. Okay. So these are the things, the characterizing water and everything is there. So these are the key technologies we require. Chandrayaan 5 is there, Venus orbital mission is another extreme. What is the key requirement? We have planned it around March 28. It will go to March 29. It will be fully operational. It will orbit the Venus. We will send a spacecraft called Sukrayan 1 to the Venus and orbit. Venus is a very hottest planet, 420 degrees. Next, it is for a thick atmosphere. 700 times the pressure of Earth will be there. You will crush if we enter the atmosphere of the Green. Okay, all the things are there. We are sending balloon, this, that, and everything. So these kind of things are more important for the Chandrayaan. For the Venus, sorry. So Venus operation is there. So we are sending a satellite to Venus to analyze their surface and map and everything. They are having lot of the thermal management is more important. How the high temperature materials, how the high temperature material, high pressure with the high temperature, sulfuric acid will be there. So all the things are involved in the Venus mission. We forgot to tell Chandrayaan-4, India's lunar sample. So here you see that you have to take the sample and come back. You have to go to moon. You have to soft land. You have to drill. You have to collect the sample, come back and dock with already the model which is orbiting the Earth. You have to dock with them, and the sample will be transferred to India. It will re-entry mechanism necessary. It is a twin launch. 2 launch vehicle is necessary to further Chandrayaan-4. So far you have seen only 1 launch vehicle. This is the first time. This is the first mission. Whether you have to launch 2 space vehicles, LVM-3. 2 LVM-3 are required for a 1 launch. It is for going and coming back. So this is called the Chandrayaan-4. This is the next project parallel with the Gaganyaan. Okay. So these are the key technologies we have seen for propellant. For all these things, the more number key is next generation launch. It must be reusable. It must be expandable also, and cost must come down. It will use advanced technology, LOX, methanol advanced. It will use green propellant. So it requires a methane infrastructure. If we are going to Mars, methane is available, well and good. We will take it there and make it. It's called inside resource utilization. Right? Launch pad is necessary. That launch pad we need short, it goes to launch the next generation vehicle, which is 30,000 kg to launch, comparing SLV 30 kg. Really next generation. So it rely on the propulsion technology. What are the propulsion technology? Long-term and lunar missions, you see that. Building, enabling, I will summarize. Enabling technology development. So you must dock. Very important. We want to dock in the orbit, return sample mission or BAS mission. Everything, there's a docking in the orbit is more important. Next is semi-cryogenic. We have come to solid propellant, liquid propellant, cryogenic, semi-cryogenic, then metalax. It will give you high ISP. How will you estimate any propellant system will be compared parameter is ISP. ISP as solid is around 250, liquid is around 300, cryogenic is 350, semi-cryogenic may be 420, and the metalax may give for more than 500. But electronic propulsion will give you 10,000. So as long the chemical propellant is, that is the limitation. Then comes a Guru lunar orbiter. You have to it's an entirely new structural design for the Indian vehicles. You have to CM model has to be designed. Okay, first Indian we have to send the moon in there as a man on the moon. Right, it will come up to at least 2047, 100 years after independence. We will be independently landing on the moon without anybody's help. So semi-cryogenic technology and the LVM-3 boosters there with the semi-cryogenic engine, heavily launches, such technology. That means they are monitored all over the world, etc., etc. These are the long-term technologies required. India's cosmic journey is on propellant and the other. You can see that what are the landmarks with respect to that. So if we take the advanced launch vehicle, there are 2 launch vehicles are coming down. One is next generation launch vehicle, and second is reusable launch. The next generation launch vehicle is reusable. It will land back. You can see the trajectory. You can see the trajectory. If you move the cursor, it will go. So it will land back, and it is reusable. It is the next generation is VTOL, vertical takeoff and vertical landing. Next class of vehicle is reusable launch vehicle. Reusable launch vehicle is like a space shuttle. It will land back, it will land like a plane and take off in a rocket. There only small shuttle launch vehicle for the student satellite, that SSLV type vehicle. These are the three vehicles. Anyhow, ISRO recently decided all the things will be given out to the commercial space. So advanced propulsion system, if you take, there are two systems are there. One is cryogenic propulsion, semi-cryogenic. It is 2000 ton and 2000 kilonewton. See that 2000 kilonewton thrust it will develop with the 2000 tons of propulsion. Right? So like that, there is a LOX methane instead of liquid oxygen and methane is a fuel, not hydrogen, like others. Semi-cryogenic, cryogenic are all hydrogen. So they are going to make this one, this LOX methane and LME 1100. These are the two advanced key technology which is going to be the future vehicle. So advanced space operations. What are the maneuvers in space? That is autonomous in orbit docking. It must dock like a very smoothly, like international say talking, like our Falcon 9 is carrying a Dragon. SpaceX's Dragon is running very smoothly with the international space station. That one is necessary. And we need a life supported system inbuilt satellite. That is a crew module. 3 or 4 person can live for 1 week in the space. Okay. So for that, we are going to build a Bharati Andhra section, like an international space station. Is a space operator coming in space operator. Then Chandrayaan 4 is a multiple module architecture which requires 2 launches. It will get the sample back to the Earth, taking and this one. These are the key projects and key lettering. And one more interesting area is the communication. The deep space communication is not like our low Earth communication. So we must, as long as chemical, there is ISP limitation. We must for ion thruster, we must go. Ion thruster will reduce your propellant mass, so that more payload can go. Then the quantum key distribution computing. So quantum physics is entering. Okay, a computer will go, atomic clock, critical components, traveling wave tube. So all the things are the amplifier, etc., electronics, this one. And dual trajectory and orbit builder, orbit propellant filling, everything is going to be integrated in the future. So this is apart from that, we have a advanced manufacturing, orbit mining. So all the 3D printing, all the things are entering. And finally, the commercial of Earth is going to be handed over to the private companies, where you have lot of chances to become a startup and do that. So from Lunar 2025, we are starting from 2028, 2050, we will land at that. So that is the policy. These are the four things we have discussed. This is a comparison between the various propulsion. Semi-cryogenic, it is 200, it is SCE, semi-cryogenic 200. So this is the LOX with the Carolox. It is called isoresin or LOX with regard to kerosene. So liquid oxygen plus methane. Here it is xenon, electrical. Air breathing, ramjet. So these are trust level. You're going to see that the electrical ion is very good, but the trust level is 300 millinewton. But in a semi-cryogenic, you can see it is 2000 kilonewton. Okay, that was we need. That is the order of the thrust we required. If we use nuclear or electric, it must be order is that much. All electrical, okay. All the things are there. So we would, these are the things we just bet and everything is there. So this is what we have in the future project. Now it will open for question. Okay, you can ask the question. Yes. No question. Yes. Question, please.
Okay, sir. So can I just allow them on the mic, sir? Like one by one? Is it
Sorry?
fine?
Sorry?
Can I just allow
Yeah,
them
yeah.
to ask
Unmute them,
everything?
unmute them, let them.
Okay, okay. Everyone just raise your hand if you're having any doubts. Please raise your hand, everyone. Please raise your hand. Then I'll just call your name as usual and you can just
Yeah, one
ask
by
your
one you
doubt.
can allow them.
Yeah,
Yeah.
okay. You can just ask your doubt as you already don't know how to ask.
Second, their
The
opinion
first
about
is,
the lecture also. Yeah.
yeah, yeah. First is the Saksham. Saksham, just ask your doubt, please.
Yeah.
Saksham, am I
Abhimanyu
audible?
is saying there are a lot of people, one by one here. Ask them, allow them to ask question.
Only one doubt. Please ask your doubt. Yes, you can go.
Am I audible?
Yes, yes, sure.
Yeah, yeah. You're visible also. Very young boy. Hmm.
Okay, sir. So my question was, when a rocket is launched, we have its fuel. So when it is launched, then it passes through the thermosphere, which is extremely hot layer of the atmosphere. So why? So how does it survive there?
No, kindly somebody translate what he is talking.
When the rocket is launched, it passes through the layers of the atmospheres of the Earth. But when it passes through the thermosphere, then the temperature is very high there, more than 100
No, what
degrees
is he asking?
Celsius.
Kumar.
So, how does the rocket survive in the thermosphere?
The rocket, I think you are correctly with the atmosphere you're asking. How it is going in the atmosphere, right? It is only
Yes, sir.
70 seconds. It will cross atmosphere. The rocket will not be long in the atmosphere. It will cross within 70 seconds. It will cross atmosphere. That's all. Second, not even a minute. But it will experience a lot of bending load because of the aerodynamic load will be there only in the atmosphere. And most of the rocket fail only in the atmosphere because of the aerodynamic load. So it will bend, it will break the vehicle. Well, but the rocket speeds are more. The trajectory is so few, it will escape the atmosphere. For few seconds only it will be there. Satellite will cover by the heat shield. After the atmosphere, the heat shield also will go. It will be in space. There is no worry. Huh? Every
And
rocket will pass the atmosphere.
And sir, I had one more doubt that how does the rocket like you see that ISRO has three satellite systems GSLV, PSN, PSLV and LVM3. So we have GSLV rocket for the planetary missions, but the other rockets you see. So how why does the ISRO can't go on with the other two space launch systems?
No, no, no. What is he asking? Slowly. You talk slow.
My question was we have three satellite launch systems. You see GSLV, PSLV, and LVM3. So only GSLV rocket is capable for producing the planetary missions, but other two rockets are not. So why is it so?
No, no, no. PSLV rocket mostly low and were image satellite. One thing. Okay. Which is very low weight. And secondly, PSLV is mainly used for commercial purpose. Commercial purpose means other countries has given rocket satellite to launch. So that capacity and it is very economical to launch with the PSLV. LVM3 will costly. Launching is very costly. It requires lot of propellant, lot of precautions and everything. And PSLV we launched more than 60 times successfully. But LVM3 and everything only 9 times, 9 to 10 times. But yeah, PSLV is launched for long thing. Okay, so that is the reason why we are mainly depend upon PSLV. So it depend upon the payload weight. If we give a heavy satellite to be launched, we will go for the LVM3 only. If we go for a 1000, 110, 1.5 ton, then we'll go for PSLV, which is more economic. And what is the purpose or mission also there? If we want to go to remote sensing means you have to use PSLV. If we use a geo communication means you have to use GSLV only. Right? Thank you.
So, sir, as you are saying, then why does ISRO did not build another space launch system since ASLV retired in 15th August 2020. In 6 years, they were able to build, but they did not. Why is it so?
No, your questions are very long, like poetry. You just tell your question in 2 lines. What is your question?
My main question you answered, but the second question was the last space launch system ASLV retired on 2020, but after that we had 6 years then, but still
Yeah,
ISRO
somebody
has
translate it.
three.
Still, it is flowing. Not clear. The question is not
So
clear.
my question was, why does ISRO did not build
Put it in the
any
chat box.
other space launch
Okay,
systems?
next people, I will come back to you. Only two questions. Others are waiting.
So he's just trying to ask that if ISRO is having lots of satellites and rocket, then why he's not building the new one and the different type one? But the point is, whatever the requirement ISRO is having, they are being able to fulfill by using the PSLV, GSLV, and an LBM3. So whenever they're going to need that, they'll definitely do that. Okay, Saksham? If you still have any doubt, you can just put that. Okay. Next is Abhimanyu. Abhimanyu, please ask your doubt. Abhimanyu? Hello. Please unmute yourself and ask your doubt. You're not being able to do or what?
Yes, done. I was not able to do it. Now I can do it.
Yes.
My
Please ask your doubt.
my question is, will ISRO in the future have a permanent Mars human base? Hello, sir.
Sir is listening. Wait a second. Hello, sir. Hello. I think there is some network issue. Let me just. Hello, sir. I think sir is having some network issue. Wait a second. Let me just. Yes, sir is here only. Let me just. Sir, you are muted. You are muted, sir. Please unmute yourself, sir. You are not audible, sir. Uh, you are muted. Like your device is muted, sir. So that's why it's not audible to me. Yes, it's done, sir.
Yeah, now tell
Yeah.
me.
Abhimanyu, just ask it out quickly, please.
Yeah, lot of rain and thunder here. That's the reason why it disturbance. Okay, talk quickly and clearly. Abhimanyu. No.
Abhimanyu, just ask it out.
Yeah.
So, sir, will ISRO in the future have a Mars human base?
Which?
Will ISRO have a future Mars human base?
No, there is Mom 2 is going to come. Right? Mangalyaan 1 is over. Mangalyaan 2 is going to come. Right? Your question is, who will be the future? There will be a Mars mission.
Will ISRO have a future Mars base, human base? permanent human base on
First we
Mars?
go for the moon space. We have not even reached the moon still. Still, man is not in the orbit. We can send only satellite to the Mars. It is not that much easy. One by one, we must go. What you are going to do in Mars suddenly, if you are going to set up a colony there? But first, you must have the vehicle to take you to the Mars, right? Now we are able to send a satellite to orbit the Mars only, not even landing on the Mars. So step by step, we go, and we are having a lot of, I told you, how many programs are there. 7 programs are under this. Step by step, we'll go. Definitely will go. But it take years and more money. Next question.
Yes.
Okay, so
Next
the
question. Niladri, please ask it out. Niladri Das, please.
Yeah.
Just unmute
New
yourself.
person.
Unmute yourself.
Yeah. Yeah.
Please speak now.
Good evening, sir. Is my voice audible?
Yes.
Yes.
Yeah, audible. Tell me.
Sir, I had a conceptual doubt, like what are the primary trade-offs between dynamic pressure and engine thrust throttling during early atmospheric flight?
No, engine not starting. No, what's okay? During atmospheric flight?
Sir, during atmospheric flight, so what are the primary trade-offs between dynamic pressure and engine thrust throttling?
No. What is your question?
So, like what are the primary trade-offs between them?
What is a brain?
Primary trade-offs
Between? Good. Primary trade-off between?
between dynamic pressure and engine thrust throttling.
Okay. See, dynamic pressure is half rho v square. Correct? Half rho v square, where the thrust is relative with the velocity.
Okay,
Right?
sir.
So, if engine start burning, solid propellant, there is no control. Liquid propellant thrust can be controlled. So, what they will do, they will form a thrust versus time curve. It is called M curve. First, it will go up, thrust, then they will reduce the thrust. So that velocity will be reduced, where the density will be maximum. So there are 3 conditions, they will be very clear. One is maximum dynamic pressure, maximum velocity, maximum, that means maximum thrust, maximum density.
Yes, sir.
Okay. The half rho
Yes, sir.
v square will be of the 3 parameters, they will be adjusted. If we go altitude, rho will come down. We can increase the speed. So for that, they will trim the thrust versus time curve such that at the maximum dynamic pressure will occur around 70 seconds. They will reduce the thrust at that level for some time, like a M curve. Thrust will go up, so come down, then again go up when it go out of atmosphere. So they will trade off between the thrust and the velocity. Dynamic pressure value. So there will be, it is called M curve. They will shape it such that they will do it. Because this is a liquid propellant, you can control. You can control the thrust. But solid propellant, you cannot control. Once ignited, it will go. For that only, this kind of grain modification they will do, such that there will a type of thrust curve will be like a M curve. So thrust will come down during a maximum dynamic pressure condition.
Okay.
What is the next question?
Nitjana, please ask it out. Please unmute yourself. Make it quick. Yes.
So my question is, when you look at the missions ISRO is planning today, what problem do you think future engineers will be solving that we aren't even thinking about yet?
Repeat again.
Like when you see, we look at the missions like ISRO is planning right now, what problems will be the future engineers be going to solve that we're not right now preparing? Like what will the future engineers have to be prepared by?
Problem is what we are right now. What is the problem? Lot of people are leaving the ISRO. Important people are leaving the ISRO. So that is a major problem now. sometimes the propellant may not be the future. Future technology, the engineers may not be available. They are all going to the private sector. That is only the major problem for ISRO. Otherwise, technical, raw material, everything is available. And it is cheaper also in India. So we didn't see any space problem. Only thing, the human resource. Yeah, they should not go to abroad. They should not go to foreign countries. That is the problem is the attrition. It is called attrition problem. People leaving ISRO. Voluntary resignment, general resignment, all the things. That is the only major problem we are facing. Otherwise, there is not much problem. There is a good encouragement from the government. Good budget is there. We are given 25,000 crore for Gaganyaan. Initially, we are asking only 10,000 crore. Okay. So all the things were available here. Only thing, human merit. That's all.
Thank you, sir.
Next question.
Lakshmi. Lakshmi, please ask her out. Lakshmi.
Okay. I'm like, Zahif is not able to continue the session. He asked the question: what real changes do you think the government have to make improve our space research and missions quality and capacity?
Yeah, now they have done a lot. They have handed over all the rocket to the private people. InSpace is working well. InSpace, all the test facilities are available. They are doing well. They will do much more. So now they have given the large vehicle for commercialization. They are allowing the startups to participate in the ISRO, right? And they are, but only thing we are not using. They have given lot of program for students to participate in the ISRO. Umiga, a lot of modules they have loaded in the online. We must download and read. All the things are there. We must visit ISRO center. They are open. So a lot of good things are now happening. Next.
Okay. Allow, please ask her out. I don't know how it pronounced. Please ask her out.
Yeah.
You're not audible. Just unmute yourself.
Hi, sir. I have
Yeah.
developed a smart bike speed controller system. My system automatically controls the bike speed according to the government approved road speed limit. This can help improve road safety and reduce accident cases by overspeeding.
My voice is very feeble.
How-
Some of the words are not at all I am getting. Talk loudly, confidently, slowly.
Yes,
Yeah,
sir.
tell me.
So I have developed a smart bike control system.
You have?
I have developed a smart bike speed control system.
You have developed a what conversion?
Sir, I have developed a smart bike speed control system.
Speed
Okay.
control.
A smart bike. Smart bike
Smart
control
bike.
system.
Okay,
Yes.
right. Oh,
Okay.
okay.
Yeah.
My project automatically control bike speed limit in government approved speed road speed limit. Yes, sir. I have received a second place this project in
Okay, good. Congratulations.
Science Expo. So my question: how can I take this project forward, get a government recognized and or patent support?
Do it for a rocket motor. Try something in the rocket motor. Because motor they will not take in ISRO, no. Only your transport department will take you. You're a local state. But if you want to come in ISRO, do something related to rocketry or satellites. Then it will be there.
Yes, okay.
Okay. Then yeah, they want rocket expertise. Next question.
Jadip, please ask your question. Unmute yourself and ask her out.
Yes, sir, definitely. Good afternoon, sir.
Good afternoon. Good afternoon. Good evening.
Sir, I have. Sorry, good evening, sir. Sir, I have two main doubts, sir. Can I ask you if you get my permission?
When?
I have two doubts, sir. Can you give me permission to speak?
Yeah.
Yes,
First,
yes.
you have to ask one by one.
Sir, my one doubt is, as in the project Gaganyaan, we are sending some astronauts to the space, sir. So, if unfortunately the astronaut got stuck in space like Sunita Williams, we have some backup plan for them or not, sir?
No, astronaut. You are talking about astronaut, right?
Astronaut, yes, sir. In the Gaganyaan mission,
Yeah,
sir,
yeah.
we are
What is your doubt?
sir, if unfortunately or somehow reason, sir, they have got stuck in the space, sir. So we have any backup plan for them?
Backup plan, you have to return. If you feel sick or something happen, you have to return to home. And moreover, lot of medical facilities are there in the International Space Station. Okay. You are telling a space means ISS only, right? In the orbit, you will come back immediately. But if you are long stay, some problem is there. Lot of medicines and everything is there. Even the worst case, recently also, they will return to Earth immediately. The vehicle will go. The next vehicle they planned, they will be coming back. So China, there is not a big this one. Like this only. But the only thing, who will bring them back is the problem. That they have to manage. That they have to discuss with NASA. Will discuss and send the rocket to get them back. Recently also they have done that. So somebody fell sick, you have to come back. There's no other way.
Sir, my
Yeah,
second doubt
nobody
is,
had died
sir,
in space so far.
yes, sir, till now. Sir, my second doubt was, it will be any other future scope for the little astronaut to become astronaut from education field?
So what to do for a become astronaut? That's what we're asking, right?
No, sir. Any further scope to become astronaut in India? My education field.
What is he asking for astronaut?
No, sir. My educational field we can do.
No, don't change the question. Same word you repeat again.
No, sir. My doubt was by educational field, sir, we can become in ISRO sir, astronaut and all.
Your education.
Yeah, from
I
education.
am not getting that part. Astronaut, I am hearing.
Sir, see, sir, like till now the astronaut was chosen from the AIR, sir, Indian Space.
Somebody can translate. Not clear.
Okay, so could you just speak louder and remove that headphone?
Yeah,
It's
something
so
little louder.
echoing. Like I'm not
Don't
even being
put your
able
finger
to.
on the mouth. Yeah, don't. Right.
2 minutes.
Okay. Till then, Niralya, please ask your out. Niralya, please ask your out.
Educational field we can become astronaut in India, sir.
Astronaut in?
India, sir, from educational field.
Yeah, astronaut you can become in India. They are recruiting. Already 4 Indians are going to be astronaut, right? Subhash Shukla and everything. But there are
Yes, sir.
conditions are there. You have to have 2,000 hours of flight. Okay, right now they are only taking pilot officer. Though on the working in the Air Force will get into astronaut.
Okay, sir.
Okay, because the minimum condition is you must have 2,000 hours of flight experience. That you will get only in the Indian Air Force. So right now you must be a pilot officer in the Air Force or a commander, group commander or wing commander. So you have a fair chance to become an astronaut. Later years, coming years, even the civil person like you also became astronaut. Right? Depend upon they will give you some small training and you can become astronaut. Okay.
Yes, sir.
Yeah, next Nirlala.
Niralya, ask your out.
Yeah.
So, what are the differences between PSLV and GSLV?
See, the question is very clear. His voice is also very good.
Yeah.
So like this, everybody will ask. She is asking very nicely, sharp voice. Like that you must ask. So PSLV and GSLV, first this one. PSLV is for polar orbit. Polar orbit means it will orbit South Pole and North Pole with a 400 kilometer away. Okay, it is for a polar orbit. It can launch satellite in the circular orbit, away orbit, even up to lunar it can launch. GSLV is for communication satellite. 40,000 kilometers away it has to launch. That is their major difference. Okay, their orbits are different. It needs more propellant for GSLV than PSLV. It is very costly to launch in GSLV than in PSLV. PSLV is proven. We are around some 60 times we are like the launch fleet, very reliable. Okay, these are the differences. First orbit is different. Okay, this polar orbit is a geosynchronous orbit. Both are perpendicular to each other. One is covering pole, another is along the equator. Equator is this way, polar is this way. Okay, so the orbits are different. Thanks.
Okay.
So another question.
Hmm.
So what are the advantages of stage separation?
Advantage stages are important because each stage give different velocity, right? See, let us say PSLV is 4-stage. Why it has 4-stage? We want what is rocket is doing for a satellite. Rocket is giving a velocity of 7.8 kilometer per second or 28,000 kilometer per hour speed. If we give the speed, then only it will orbit the Earth. So this speed is given by the rocket. Rocket have stages. Each stage will give a velocity. Say, right? So we need not carry always the empty stage. First stage will give 2 kilometer per second. Right? Second stage will give 4 kilometer per second. Third stage will give 6. Final stage will give you 7.8 kilometer per second or 28,000 kilometer per hour. So we can stage by stage go, we can remove the stages. The empty stages will go down. So we can reduce the weight. You will get more velocity for that only. If we gave only one stage, then entire period you have to carry that empty stage. So here we can save separation, we can reduce the weight of the rocket, total weight of the rocket. If the weight goes, more oscillation. Oscillation F is equal to ma, or acceleration is equal to F by mass. The mass is going to reduce, the force will be more, oscillation will be more. The model that we found.
Thank you, sir.
David, ask your out. Hello, David. Unmute yourself and ask it out. Make it quick, everyone.
Can you explain about the Vyomitra robot again?
What is that?
Can you explain about the Vyomitra robot again?
Yeah, Vyomitra report is a half robot, only up to chest, right? The different part is done by different material. It will have sensors. It will see. It will monitor the instruments. So it will behave like a woman using AI technology. So it will sit down and see and do the instrumental during the flight. It will take a reading and send to her. So it will behave like a human being in the space, but it is not a human being. It is a robot. Okay, then like that.
Okay. Next is the Motorola Moto G72. Hello. Just put your name first and ask it out. Ask it out. Hello. You are audible. You are eating something or what?
No, sir, no, sir. Nothing.
Yeah, please ask it out quickly.
Okay. Sir, when will the NASA program be launched?
When will be?
When will the NASA program and India's part of the IS be launched?
No. His voice is not listening. Your voice is not heard. And the YouTube also reporting my voice is not getting.
Sir, when will NISAR be launched?
Which will be launched?
NISAR. Nisar.
Nisar.
Yes, sir.
Nisar is launched already, right?
Yeah, already launched, I guess. Yes. Okay. Sir, we can go for the next question. Niladri, Niladri, please ask it out. Hello, Niladri. Please unmute yourself and ask it out. Unmute yourself. Yes.
Done, sir. Done, sir. Thank you,
One
sir.
good question is coming. How to become a ISRO scientist? ISRO scientist you can become in. When David has asked this is a very good question. Whether everybody must understand. ISRO, if you want to become ISRO, there are 3 ways are there. One is if you are +2, you must take MPC. You must write JEE main and advanced. If you get a good mark, you can join the IAST. Then after 4 years doing in IAST course, you will be automatically selected to ISRO. Next one is, another one is from, you can join any college, any engineering, any branch, but you must write ICRB exam. Like a UPSC exam, there is ICRB exam. In your advertisement will come, you can write and join. Otherwise, you can do doctorate in the related field of SpaceX. You will be called by the ISRO for an interview and get selected. Okay, these are the 3 ways you can join ISRO.
Yeah, Niladri.
Yes, sir.
Niladri, please ask me.
Sir, is my voice audible? Like it's clear or not?
Yeah,
it
it's
is
clear.
Yeah, yours is
Okay,
clear.
sir. Sir, what material carbon-carbon compositions and superalloys from operating at even high combustion chamber temperature?
See, there are high temperature materials are there. So
Okay.
depend upon nozzle needs a high temperature material,
Hmm.
right? There are heat seal will absorb heat from the ablative materials. There will be common composite, sandwich structure, nozzle, there will titanium, all the things are, even steel is used for PS1 motor. So wherever heat is there, there will be a different mechanism will be there. By cooling the part, like we will cool the part, try to cool the part to reduce the temperature. So there are some high temperature material like a tungsten, graphite. This will be used in the places where it is required. So it is not one material. Rocket is contains a lot of material depend upon the each part. Carbon composite is there for a lightweight. Okay, high temperature another material is there. Titanium. Like this, we will be using depend upon the parts and the stress subject to. If the high temperature is coming here, we will use another part. High stress is coming, you will do another part like that. Each component
Okay,
is using different parts in there.
Yes,
There's
sir.
a list is there.
Thank you, sir.
Harshda Pathak. Hello, Harshda. Please ask your.
Sir, am I audible clearly?
Yes,
Yeah.
So hello, sir. I am Harshada Pathak from Maharashtra, and I'm a postgraduate student who has completed MSc Physics recently. And all your session was very nice, and thank you so much for this opportunity. I would like to ask three questions. My first question was how to choose or how to select what roadmap should be there for choosing a field for PhD, particularly in space science, like in astronomy or astrophysics.
No. Just ask the question alone. How to?
So how to choose, how to select a particular field for PhD?
Your voice is cutting and you're freezing. Yeah. How to?
Sir, am I audible?
Yeah, you're audible. Just speak louder and clear.
Okay, sir, my question was how to select or choose a field for PhD in space science after MSc Physics.
Okay. After MSc Physics, ISRO is having a direct register. If you log in ISRO site, there is a called direct register. In the direct register, they have given what are the topic ISRO research topics, what are the topics ISRO need, what is the requirement of research, in which area, the topic they have given sector wise. So telecommunication means telecommunication, propulsion, they have given the topics. Select one of these topics and do a research. You will be get selected in ISRO.
So my second question was, does ISRO recruits the PhD scholars or postdoctorate scholars who have completed their PhD from abroad?
They select PhD candidates. Okay, depend upon our research area, what research area he had done, that is given in the direct register. They will select anybody, any Indian they will select. Any Indian doing a degree abroad who is eligible to join ISRO. But any foreigner doing in Indian university is not eligible to join ISRO. Understand? Any Indian doing in any foreign university is eligible. For any foreigner who is doing in Indian university is not eligible. Right? That's it.
Okay. And sir, do we have to appear for any exam for the PhD in ISRO?
ISRO, if you are +2, you have to write advanced JEE. Main and advanced JEE, you have to write to join IAST and join ISRO. If you are BE, you have to write ICRB exam or sometime GATE exam.
Sir, I am a postgraduate student. I've completed my MSc in physics.
So
After that, I went to
postdoctorate, postdoctorate, see the advertisement. Sometimes they will call doctorate. ICRB exam, sometimes they will call doctorate for recruitment. Against that post, you apply. There may be an exam. ICRB exam will be there. There is a separate syllabus. There is a separate question paper. They will conduct ICRB exam and select you. Sometime your PhD topic is very close to the ISRO requirement. They will call you directly without any exam and make an interview and so on. Awesome.
Okay. And so my last question was, are RGO and MnO2 nanocomposites like graphene oxide, reduced graphene oxide, and manganese oxide nanocomposites are used in the field of space science, particularly for sensing?
Nothing is clear. Nothing is clear. Your question is like a river, it is flowing. That's all. Nothing is clear.
I'll ask again, sir.
So simple sentence. Don't be fast. Simple sentence. You are doing nanographite, right? And what do you want your question? Simple sentence, slowly talk. Now ask.
Sir, are reduced graphene oxide and manganese oxide nanocomposites are used in the field of shielding or sensing in space science?
See, the ISRO recruitment is against advertisement. The advertisement, what they ask, your eligibility, right? Your degree only speaks. Your highest degree speaks. What you are doing, what you are practical, all the things will help you to write the exam efficiently or face the interview well done. That's all. But they will ask you the minimum qualification will be given there in ISRO. We want MTech in nanocomposites. If you are MTech in nanocomposite, apply. But you are MTech in ECE. I have done one subject in nanocomputer, not applicable.
Sir, I have
You must
completed my
match with
MSc
the
in
degree,
physics.
what they are asking. It is not there, you are not. You may do a lot of things, right? As a project, as a interest, as a subject, as a internship. You can do a lot of projects. But when it comes to employment, it is your maximum degree in what? They want electrical, they want mechanical engineering, means you cannot say, I have done in composite. Do you have mechanical engineering degree? That's all. Over. Like that. Yeah, next.
Thank you, sir. Thank you, sir.
Himali, hi, Himali, please ask your doubt.
Yes, sir. Good evening, sir. My name is Himali Kathiria. I am graduate in mechanical engineer. My question is, why do we invest so much in space exploration when we still have technological gaps in many areas of our daily lives? And how does investing in space technology ultimately benefits common people?
Yes. This was asked to Dr. Vikram Sarabhai. The same question was asked to Vikram Sarabhai when he started ISRO. A lot of people are starving. When ISRO started, when we launched the SLV3, there was a drought in the country. But not launching SLV3, drought will not go. Drought will be there, suffering will be there, poor will be there. At the same time, advancement like atomic and space must be there. Because of the space only, we got the communication now by satellite. How many TV channel you are seeing in the TV? It is by space.
Yes.
Right? How we are medicine, telemedicine, everything, all tele is working through space. Space have 57 applications. Agriculture, transport, health. You take anything, a satellite and space is there.
Okay,
right?
sir.
We want to avoid food. There, I will tell you in Orissa. I think there was a storm. There was a cyclone. 1 million people died. Lot of after having satellite image technology, same type of cyclone comes in after some years. Not even a single person died. This is because of
Okay.
the satellite images. Okay, that way. It is how we are applying for the benefit of common people. And
Okay, sir.
Kalam also told it must apply to the common people. Okay. Right.
Sir, we'll take three more doubts and we'll just wrap up it. Anirudh, please ask it.
So it's the last question. Time is there.
Uh, there is a two questions. So Anirudh and there is a one kid. Anirudh, please make it quick.
Okay.
So
Sir,
quickly ask the question.
yes. Could you specify what materials will be used for Project Surya, the rockets? Because we mentioned reusability.
Yeah. Tell me, what is the question?
In the Project Surya rocket, which is the successor of the current rockets, what
No, no.
materials will be used? Because we
No,
mentioned
voice,
that it will be
louder. Voice.
Okay, 1 second.
It's
Only your
not
accent
audible.
only seen. Yeah.
Yeah, this is always a problem. My bad. Sorry, sir.
Now ask
Yeah,
me.
Yeah. In Project Surya, the rocket, which is the successor of the current SLV-3, since we specified that it will be reusable, what materials will be used?
No, I told you, the different parts are made by mostly it is duraluminum. Okay, the
Okay.
space shuttle type. Or carbon composite.
Okay.
Or tungsten. Or graphite. Depend upon the depend upon the part.
Okay.
Right.
One
It's not
last thing.
one single material. Even PSLV first stage is CDV 16 steel. Whereas
Okay.
aluminium is for the second stage and third stage.
Okay.
Okay, like the mostly it is aluminium. Rocket is
Okay.
made up of aluminium, except some few parts for thermal, tungsten, and other thing. There are some
Okay.
titanium bottle is there. For a small bottle is titanium where the gas pressure is high. So like that, but major rocket part is aluminium.
Okay.
And
One
carbon.
last question.
Yeah.
About the same thing. Do you believe that stainless steel and carbon fiber could be used since SpaceX used stainless steel and Skyroot is using carbon fiber?
Yes. See, finally, Starship, what is the material it is using? After all the
Stainless steel.
analysis, stainless steel.
Yes.
Starship, which is the advanced material, finally, because it is cheaper.
Yeah, mass production.
Finally, what is the cost comes? Aluminum is costly, but aluminum is better for this one. But he is using stainless steel. So these are all depend upon your cost, your requirement, availability, all the things are there. But aluminum is lightweight and strong. That is the load coming on the structure will be decided. That will decide what is the material you to use.
Okay. Thank you, sir.
Okay, we'll take the last question, sir. There is a kid, Lathik. Lathik, please ask it out, and we'll just end up this session here on this.
Sir, you told there was the geometry robot. Like you told that was half robot. What is the other half of the robot?
So we're talking about robot, I can understand.
Yeah,
What
he's
is the
asking
question?
about Vyomitra, sir. Vyomitra, he's asking if it is the half one, then where is the half one, sir? He's
No,
asking
it is a
about
half one only. The half one, like sitting boss, it is a half one. It's not a full standing robot. It is a chest level robot only. Okay. What is a robot will contain lot of AI and sensors. Based on that, it will be activated. Actuator will be there. It will activate the robot for doing the work. It is a half robot woman. You like it? You like her? Do you like her? Is a woman. Okay, not girl. Okay, right, next.
Okay, sir. So
right.
I think
Thank you. We'll meet again
this is
in
the
some other
last
one.
one, sir. Yeah. Everyone, we'll just end up the session here only, sir. Everyone just please turn on your camera so we could just click a picture of today, and we'll just end the session here only.
Right.
Okay.
Thank you very much.
Everyone, please. Okay. Thank you so much, sir. Thank you so much for joining us today again, and thank you so much, everyone. I hope you just enjoy the session. Yeah, everyone, please turn on your camera so we could just capture this moment again, and we'll just wrap up it here.
Okay, right. Thank you. It is streaming also,
Bye.
right? Thank you. Bye.
Yeah. Okay. Bye. Bye, everyone. Good night. Good night, everyone. Done, sir.